One of the instruments that can be used for determination of various pollutants in marine environment is laser fluorosensor. So, what is laser fluorosensor? Laser fluorosensor is an active sensor. They are useful instruments because of their unique capability to identify oil on background that include water, soil, wind, ice and snow. They are the only sensor that can positively discriminate oil on most background. Now move on to fundamental principle of laser fluorosensor. The principle of laser fluorosensor operation are classified into active and passive sensor. Passive sensor are those that measure naturally available energy such as ray of the sunlight, while active sensor means they provide their own source of excitation. Laser fluorosensor can be operated on board an aircraft to analyze physical and biological parameters of water such as turbidity, algae content, or to detect marine pollutants such as oil spill. Laser fluorosensor is mainly used for analyzing deliberate discharge of oil into the sea. So, how laser work? Laser fluorosensor works by employing the property that certain compound, mainly aromatic hydrocarbon, in the oil absorb ultraviolet light and re-emits portion of this energy in visible region of spectrum. Few other compounds show this tendency. Hence, fluorescent emission strongly indicative of presence of oil. Different classes of oil yield slightly different fluorescent spectral signature and intensity. One can therefore differentiate between different classes of oil under ideal conditions.
The next instrument is Hitachi F7000 FL spectrophotometer. What is Hitachi F7000 FL spectrophotometer? Actually, Hitachi offer high performance fluorescent spectrophotometer with high sensitivity, suitable a wide range for application from teaching, routine analysis and basic research to advanced research. Next, advanced system available with accessories such as microplay reader, intracellular calcium polarization and quantum yield measurement of powder. So this is example of Hitachi F7000 FL spectrophotometer. Do you guys think the purpose of this instrument? So actually, this instrument for water quality analysis, they detecting the presence of different type of oil in seawater. So this is example of sample seawater oil that collected in seawater. How does this instrument work? This instrument measure of trace sample can be measured as long as 1 times 10 until 12 mole per L fluorescence. To complete within 1 second of the entire wavelength range for measurement. Concentration range measurement is 6 order of magnitude. So this instrument connected to the laptop with specific software inside it. So what the fundamental principle of Hitachi F7000 FL spectrophotometer? So the highest sensitivity at SN 800 peak to peak in class. So the faster ultra high speed can at min in class. So compare design with volume ratio of 60,000 nanometer per minute in each class. So compare design with volume ratio 2 per 3 and 30% reduced mass weight, and compare to F4500. 3D time change measurement mode capable of following time are changed at multiple wavelengths.
Me is Sensor. Now I'll be talking about colorimetric sensor. So this sensor is a sensor that changes color when it detects changes in physical or chemical environment. It is evidenced by Aberlit in 2019. So to explain how it works, I'll be using a report from Chang et al. 2020. Chang and his colleagues were measuring pollutants like saxitoxin, which is also known as a paratic shellfish toxin, produced by dinoflagellates during half-algae blooms. So in the report, this sensor uses gold nanoparticles and camera to detect saxitoxin. They will cause the gold nanoparticles to accrue together and the solution will change color. The principle behind this experiment is that a specific molecule, which is XS-atemer, will interact with target molecules, which is saxitoxin, and then they will bind with the gold nanoparticles. These saxitoxin atemer will then separate from the gold nanoparticles here, and then the gold nanoparticles will then form a ball and then produce a color change. So the first step is the gold nanoparticles will aggregate together to form a ball by adding NaCl. Second step is the saxitoxin atemers are then used to separate the gold nanoparticles individually by binding with the gold nanoparticles. Third step is that after saxitoxin is bonded with saxitoxin atemers, roll nanoparticles will form a ball and then they will produce a color change. So the color change that they will change from red to blue purple, the peak shifting from 520 nanometer to 650 nanometer, which means there's an increase in sulfatoxin concentration. Thank you.
Fourier transform infrared spectroscopy (FTIR) is a technique that can obtain the infrared spectrum of absorption of solid, liquid, and gas. They measure absorbance of the infrared light energy of sample by different wavelengths. This is used to determine the material molecular composition and structure. The theory is the bond between different elements will absorb the light at different frequency. Then infrared light spectrometer, which produce the output of infrared spectrum, can measure light. FTIR usually used at the water content determination and composition. So how to operate the FTIR? Actually, is easy. We just connect our laptop with the FTIR and sign in the software. Then first we clean the sample holder to make sure that it's not contaminated. Place the sample on sample holder and press apply and start on the laptop to start to collect the spectrum. Then scan the surface image of sample. We have to wait some minutes for the data process. After that, it will identify and show the composition of the sample. And at the last, don't forget to save our data in laptop.
Polarography. What is polarography? Polarography is a voltammetric measurement whose response is determined by the convection or diffusion of mass transport. What is the principle of polarography? A study of solution or of electrode process by means of electrolysis with two electrodes. One electrode is polarized and the other one is unpolarized. The former formed by mercury regularly dropping from a capillary tube. Use saturated columnar electrode as the anode and the dropping mercury electrode as their cathode. How it works? First, set up the apparatus. Second, use polarized electrode and reference electrode. Third, apply the voltage range between 0 until 3 volt and capillary dip into the solution to be analyzed. And make sure the mercury dropping we adjust so that the dropping will be about 2 until 7 seconds per set. And remove the drop as we get measure the current and the voltage. Okay? Using this technique, inorganic and organic compound can be analyzed. Even low concentration of sample can be analyzed too.
Biosensor. Biosensor is an analytical device consisting of immobilized biological material in direct contact with a compatible transducer that will convert the biochemical signal into measurable electrical signal. Principle of biosensor: the analyte connects to the biological object to shape a clear analyte, which in turn gives the electronic reaction that can be calculated. Example, the analyte is changed to a device which may be connected to the discharge of gas, heat, electron ion or hydrogen ion. Characteristic of biosensor: first, linearity should be high for detection of high substrate concentration. Second, sensitivity, value of electrode response per substrate concentration. Third, selectivity, chemical interference must be minimized for obtaining correct result. Fourth, time response, time necessary for having 95% of the response. Type of biosensor: electrochemical biosensor, amperometric biosensor, optical biosensor, piezoelectric biosensor, thermal biosensor. Type of pollutant that can be analyzed: various toxic substances such as pesticide, heavy metal, and so on. Then oil. SMS project for seawater pollution, its detect marine alga toxin, toxin alga, species, pharmaceutical, chemical compound. The biosensor will place on a buoy in the ocean at defined location and depth. will be able to analyze the quality of seawater in real time. Data collected by the sensor are stored locally in coastal points and platforms and will be forwarded to a remote central node through a wireless connection.